Hey, welcome to Zona Mechanica. There is an NATQ on temperature stress. Figure at the margin indicates the weightage of the question, that is 2 marks. A 200 long stress-free rod at room temperature is held between two immovable rigid walls. The temperature of the rod is uniformly raised by 250 degrees Celsius. If the Young's modulus and coefficient of thermal expansion are 200 GPa and 1 into 10 to the power minus 5 per degree Celsius respectively, the magnitude of the longitudinal stress in MPa developed in the rod is, well, let us draw the figure schematically. This is the rod held between two rigid walls, okay, and it's getting heated. The length of the rod is given as 200 mm and the temperature raised, it is delta T, is 250 degrees Celsius. Okay, Young's modulus E is given as 200 GPa, that is 200 into 10 to the power 3 MPa. Okay, coefficient of thermal expansion alpha is given 1 into 10 to the power minus 5 per degree Celsius. Okay, so the question is, what is the value of longitudinal stress, that is sigma. We know that the longitudinal stress sigma is equal to epsilon into E, where epsilon is the strain. Okay, so we know strain is alpha delta T into E, right? So alpha is 1 into 10 to the power minus 5 into delta T is 250 into E is 200 into 10 to the power 3, which is equal to 500, and this is in MPa since it is taken in MPa. Since this is a numerical answer type of question, the answer is given in range. So the range of answer for this question is 499 to 501. Okay, so clearly our answer is within the range, so this is a correct answer. Hope you have understood. If you are enjoying, please do share with your friends.